Hello and welcome. So we're given a system of equations here. So we have 9x plus 12y equals -2. We have x minus 6y equals -8. And we're asked to find the determinant, not the determinant, asked to solve the system of equations for y specifically, okay, using Cramer's rule to solve. Well, technically, this is a system of equations. You can solve this however the heck you want to. You could use substitution, you could use elimination, or you could use matrices, you could use inverse matrices, or you could use Cramer's rule. There's a lot of different tools available to you at this point. Use whatever one you want to. However, it says to use Cramer's rule. It actually gave us a good chunk of the information we need for Cramer's rule. Remember to solve for any matrix, right? We got to get our coefficient matrix first. Now, there's a lot of different notation when it comes to Cramer's rule. You have your D matrix, which is like your coefficient matrix, so that'd be 9, 1, 12, and -6. Then you have your dx, sometimes it's referred to ax, right? A matrix, ax matrix, it doesn't matter. It was essentially where you take your two equals numbers, so you have a second little matrix here of -2, -8, right? You take that matrix and you essentially replace the numbers with x's in your original. So that means that we would take our -2, -8, and they would replace the 9 and 1 within our coefficient matrix. So we would have -2, -8, and then that would be 12, -6. Now if we wanted our dy matrix, that would be same thing, but instead of replacing the x's, we would replace the y number. So the 9 and the 1 would be there, and then instead of 12 and -6, we would have -2, -8. And that is your three matrices for Cramer's rule. Now it told us that the determinant that we take for our 2 by 2 matrix, that determinant is 66. That's already did the legwork for us, right? Versus now we just have to define the determinant for our dy matrix. Because it says to solve for y, technically we didn't even have to find the dx matrix. That was more than we needed to do. I just wanted to find it for anyone who is in the randomization if you're given x, that you know how to find that. Okay, so and look at that, and it's alright, so now we find the determinant of the dy matrix. So that'd be the first main diagonal, that'd be 9 times 8, which is -72, and then subtract the product of the other diagonal, so you'd subtract the other way, so that'd be -2 times 1 is -2. So we have -72 minus -2, which is, remember, subtracting a negative is a plus, it's addition, so then you'd have -72 plus 2, which is, in other words, -70. And then Cramer's rule says that once you have the determinant of the original coefficient matrix and then the determinant of the new dy matrix, your answer is just dy over the d. If you're looking for x, that would be dx over the d. And those are the determinants of those matrices, right? The determinants of those matrices. So then you'd say, all right, well, dy is -70. We just found that. D, we were told, is -66. And that is literally your solution for x. And no matter which way you solve this, you should have that same solution. Then we have -70 over -66. Negative over a negative is a positive, and that will simplify to 35, 33. 33rds? Whatever. 35 over 33, final answer. Okay, and that's it. If you wanted to solve for x instead, all you'd have to do is you just have to find the determinant of that matrix. So that would be 12 minus the product of 8, -8, times 12. So that would be minus -96. So in other words, it'd be a plus 12 plus 96, which would be 108. So then you have 108 over -66, and that would be your answer for x. So -108 over 66, and that will simplify to 18/11. So we have -18 over 11, which we actually see that as one of the other distractors. So keep an eye, know what you're solving for. If you're using Cramer's rule, all you have to do is just replace whatever column with the two numbers on your other side of your equal sign, and then you're good to go. Alright, there you have it. Thanks for watching.